This is Group 11, and we are presenting on Input-Output Organization in Computer Architecture. My name is Maxwell Kwamwamboatin, and I'm the first person presenting. Okay, so today I'll be talking about the input-output interface in computer architecture. This crucial component enables communication between a computer's internal parts like the CPU and memory and external devices such as keyboards, printers, and monitors. First, let's look at the types of input-output interfaces. So, it's like USB and SATAs, which define speed and use cases. Next, I'll explain how these interfaces manage data transfer using buffering and interrupts to keep everything running smoothly. We'll also explore how input-output interfaces have evolved over time from old serial ports to today's USB-C, meeting the growing demand for faster connectivity. Additionally, their efficiency plays a big role in overall computer performance, especially during multitasking. And finally, I'll touch on future trends like Thunderbolt or wireless input-output, which could shape the next generation of computer architecture. Thanks for listening. Hey everyone, this is Group 11, and we are presenting on input-output organization in computer architecture. My name is Maxwell. What's this?
Hello, I'm Gerald Kofitechi. Today we are going to explore a fundamental part of computer architecture, the input-output interface, or what we often call the I/O interface. Whether you are typing on a keyboard, printing a document, or viewing something on a monitor, the I/O interface makes it all possible by bridging your computer's internal systems with external devices. To help you understand how this works, our presentation is divided into 5 clear sections. Let me walk you through what we'll cover. First, we'll start with the basics. What is an input-output interface? And here we'll define it as the critical hardware system that connects a computer's CPU and memory to peripherals like mice, printers, or displays. Next, in functions of the I/O interface, we'll break down its core jobs like managing data flow, synchronizing speed differences between devices, and error checking. Then we'll dive into types of I/O interfaces, where we'll compare 4 key methods. 1. Programmed I/O, where the CPU handles every data transfer manually. 2. Interrupt-driven I/O, where devices interrupt the CPU when they are ready. Direct memory access, a faster memory method that bypasses the CPU entirely. And advanced systems like APIC and IOMMU, which boost efficiency and security. After that, we'll explain I/O bus and interface modules, the physical wiring and translators that make these connections possible. Finally, we'll wrap up with key takeaways in our conclusion to tie everything together. With this roadmap in mind, let's get started with the first session.
Hello, my name is Emmanuel Ogwe Odu. I'll be taking what is an input or output interface. So what comes to mind are like what's an input and output interface? Is the interface or like is the hardware component or the system that manage the data transfer between computer internal memory or CPU and external devices. Let me try to explain this words. Okay, so when we talk about a hardware component, it's not a software program. It's a physical piece of computer. A piece of a computer you can actually touch if you open up the machine. If you open up the machine, that's what hardware component trying mean. It's not a software or a program. It's a physical piece of a computer that you can actually touch if you open the machine. Machine like the system unit in the whole stuff. Even the hardware component, a mouse, a keyboard, all are hardware component. So these two serve as a bridge. A bridge connects two different pieces of land. The two different pieces of land. The input and output interface is the bridge that connects two different walls inside the computer. On one side of the bridge, you have the computer super fast brain, which is you have the computer super fast brain, which is the CPU. And on the other side, you have all the external tools and toys you can use every day, like the keyboard, the mouse, and the printer. So the bridge, so this input and output has bridge. So the bridge is the CPU and the physical touch, the physical device, like the hardware component. So the two bridge are the hardware component and the CPU. Okay. Without the bridge, the CPU couldn't know what to do with the keystrokes you type or you print. Without the bridge, the computer or the CPU do not know what to do with the what to type on the keyboard or what to print. If you didn't understand the command, you can even use a virtual art here, like a simple diagram with a CPU on the side, the external device on the other, and the bridge label input and output interface in the middle. So this device can be neither be input device such as I said, keyboard or mouse that sends data to the computer, or output device such as printers and other stuff. So I'll leave it for the other person to continue.
So we have the functions of input output interface. One, we have the speed synchronization. This interface ensures that the CPU operating system is speed with the input output devices. This prevents data loss due to speed mismatch. Two, we have the processor communication. This interface accepts and decodes commands from the processor. It reports the current status and recognizes its unique address. The three, we have signal control. This this control it generates and manages controlling and timing signals needed for data transfer, ensuring smooth communication between the CPU and peripherals.
Okay, so I'm talking about the functions of input or output interface. First of all, I will start with error detection. So the input or output interface checks if there is any error during data transfers, then it detects it. Data conversion. So when we enter text into our keyboards, it's what converts into what binary for the CPU to be able to what understand it. So basically, another function of input or output interface is that status reporting. So it gives reports on the devices, on the monitor. Maybe the monitor is too hot, or the screen is blur, and those type of reports. Yes, that is also another function of the input or output interface.
My name is Bedu Prince Kumeani. I'm taking you through input output interface. Types of input output interface in computer architecture. We have several types, and the types have been categorized into different kinds. So I will take you through all the types. So the first one is programmed input output interface. Okay, this one, the CPU is responsible for controlling the entire process of data transfer. So it must wait for the output input operation to complete before it move on to the next task. So because of this, it slows down the system since the CPU is constantly on output and input operation. So the second one we will talk about the driven input output interface. So this one is the opposite side for the programmed one. So inside this one, the CPU does not continuously check for input output request. Instead, when input output request is ready or input output device is ready for communication, it sends an interrupt signal to the CPU, where the CPU will pause its current task or the current work, then it will concentrate or process the input output request that has been sent. Because of this, it allows the system to be more efficient than the first one, that's the programmed one. So the third one we are going to talk about is the direct direct memory access, also known as the DMA. So in this method, it's where all the input output device can have access to the system memory direct. So the CPU, okay, so this is done by where the device bypass the CPU for data transfer. It bypass the CPU for data transfer. This speed up the process and reduce the CPU's over or workload. Yeah. So this make it a preferred choice for high speed data transfer. So the fourth one we are going to talk about is the advanced programmable interrupt control. Advanced programmable interrupt control, known as the APIC. So the APIC, it manages interrupts in the CPU. So this is how it manages. It will send a notification to the processor when a device is ready to send data. So it send a notification to the processor when a device is ready to send data. This help to manage interrupts. This help to manage, and because of this, it also help in maintaining or handling of interrupt in multiple systems. So the last one we will talk about is the input output memory management unit. Input output memory management unit. Okay, in this one is used in a visualized environment. The input output memory management unit, okay, is used in a visualized environment. It maps the visual addresses to the physical addresses. It maps visual addresses to the physical address, enable efficient memory management and isolation between virtual machines. Thank you. My colleague member will continue.
My name is Edgar and I'll be presenting on the input and output bars and interface models. Yes, so under the input and output bars and interface models, the input and output bars and interface models plays a crucial or they play an important role in facilitating communication between the CPU and other external devices. So the input and output bar stroke and the interface models are very important. They help make communication between the CPU and other external devices very, very, very easy. So another one is the input and output bars connects all the input and output devices to the system, whilst the interface bars act as a translator
between CPUs, internal bus and external bus devices here. So the interface models is very also important here. It helps, like I said, it helps translate between the CPUs, internal and external devices here. So I'll pass it on to my next colleague to take on the next slide.
I go by William Coleman Sego, and I'm speaking on input and output bus. So the input and output bus plays a crucial role in facilitating communication between the CPU and external devices. The input and output bus connects all the input and output devices to the system. A bus is a circuit on the motherboard that connects the CPU to other components. So let us see each component in detail. The input and output bus consists of the primary buses known as the system bus, which are the data bus, address bus, and control bus. The data bus carries the actual data being transferred between the processor and peripherals. That's what the data bus is assigned to do. And the address bus allows the processor to select a specific peripheral device connected to the input and send signals from the CPU to the main memory. And the control bus provides signals for managing data transfer, such as read or write, start or stop, and error directions. So with that being said, the input bus connects all devices to the system. That's the main purpose of the input and output bus.
So today I'll be taking you through the interface model. So I'm Godfred Osunyako. Interface acts as a bridge between different system or components, enabling communication, data exchange, and control. They are essential embedded system, IoT device, industrial automation, and more. Key features of interface model: facilitates communication between hardware or software, decode and process incoming data, execute status and data output commands. So let's move on to core component of interface model. Communicating purposes of communicating in core component of interface model: establishes a connection between device or systems. Method of communication. Let's use wired. Some examples are UART, SPI, and I2C. Let's move on to wireless, Bluetooth, and Wi-Fi. The other communication method in core component is protocols, MQTT and HTTP. Example of the protocol: a sensor sending temperature data to a microcontroller via UART. So let's move on to decode. So purposes of decode: interpret incoming data for future processing. Functions of the code: it facilitates checksum or error correction codes. It converts data into a usable format. Some example of the codes: decoding a GPS NMEA sentence to extract latitude. So let's move on to status command. Purpose of a status command: monitors and control the state of a system. Then common commands in status command: GET status. The GET status retrieves device. So we are moving on to status. So GET status retrieves device health. Example of GET status: battery level, signal strength. So we are moving on to reset in the status command. Reset reboots the model. So let's move on to error query. Checks for faults. It checks faults in the status command. So example of the status command: a server pinning a device to confirm it's online. So let's move on to data output command. So purpose of data output command in interface model: transmit processed data to external system. Types of the data output command: send data. So it transfers logged data. Then the second type of data output command: stream data. Real-time transmission.
My name is Desmond Fokonanayo, and I'll be taking us on the last part of this presentation, which is on the conclusion of input and output organization in computer architecture. In conclusion, the input-output organization is a vital aspect of computer architecture that ensures smooth interaction between the CPU and external devices. Through various input and output interfaces and techniques, computers can communicate effectively with peripherals. These methods can provide the foundation for efficient and high-performance systems. Also, a well-designed input-output interface can enhance system performance, support a wide range of devices, and ensure compatibility with evolving technologies. And that will be it.